Hi everyone, in this lecture we are going to discuss with numerical problems based on first two lectures. So first problem is determine the net not energy transfer charge transfer. Okay, determine the net charge transfer in a conductor during 3 seconds when a current of 3 ampere flows through it. So we have already told current equation for current I equal to q divided by t, where q is charge and t is time. So q amount of charge is passing through a conductor during t seconds, then the current flowing through the conductor will be given by q by t. So here current is given and time is given. We need to find out the net charge transfer. Okay, so charge q is equal to I into t. Okay, so current is 3 ampere and time is 3 seconds, so 3 into 3, and charge is 9 coulomb. So 9 coulomb is the total charge transfer in the conductor. Okay, then next problem, what will be the ammeter reading in this circuit? We know that ammeter is an equipment used to measure the current in a circuit. So ammeter shows actually what magnitude of current flowing through this circuit. Okay, so we know that according to Ohm's law, I will be equal to V divided by R, voltage divided by resistance. So here the voltage is 24 volt and resistance is 6 ohm. So 24 divided by 6 gives 4 ampere. So meter reading will be 4 ampere. Okay. Then third problem, find out the resistance of the conductor from V by I. V versus I curve shown below. So V versus I curve means voltage versus current curve. So y axis here voltage is shown and x axis current is shown. We know that according to Ohm's law, R will be equal to V divided by I, voltage divided by current. So here V versus I curve is given, and at some point magnitude of voltage and current is given. So for a voltage of 4 volt there will be a current of 8 amperes. So we can find the resistance from these values. For a voltage of 4 volt there will be 8 amperes current. So 4 divided by 8 will give the resistance, it is 0.5 ohms. Okay, then fourth question, find out the total energy consumption when 3 bulbs of 100 watt working for 5 hours. Okay, so energy consumption, we know that equation for energy equals power into time. So here it is given that 3 bulbs of 100 watt. So 100 is the power rating of one bulb, and there are 3 bulbs. So total power is 3 into 100, then into time. Time is 5 hours. So 5 hours. So it will give 1500 watt hour, or it can be written as 1.5 kilowatt hour. For converting watt to kilowatt we need to divide by 1000. So 1.5 kilowatt hour. So this is the energy consumption by the 3 bulbs. Then next is, how much will be the current flowing through the iron box when it operates under 220 volt and it consumes 50 kilojoule of energy for 5 minutes. So energy is given, voltage is given, time is given, we need to find out current. Again, since energy is given, we can written as energy is equal to power into time. Here energy is given 50 kilojoule or 50 into 1000 joules, which is equals, power is not given, so power P into time is 5 minutes. So 5 into 60, 60 is for converting minute to seconds. So 5 into 60 seconds, 50 into 1000 joules. So from this we can find out power. Power is equal to 50,000 divided by 5 into 60. This can be equals 1000 divided by 6. 1000 divided by 6 is equals 166.67. Okay, 166.67. So power is equal to 166.67. Okay, so we have find out power as 166.67 watt, but here we need to find out current, but we know that power is equal to voltage into current. So current can be written as power divided by voltage. So power is 166.67 divided by 220. Voltage is 220. So this will give the amount of current. This will be equal to 0.7575 amperes. Okay, so this is the amount of current. Then sixth problem, the resistance of a conductor is 12 ohm. What will be its new resistance when its length is doubled and area is halved? Okay, so for this we need to write the equation for resistance as rho L by A. Okay, and it is given as resistance is given as 12 ohms. Okay, then new resistance. For new resistance, when length is doubled, so length become 2 times of L and area is halved, so A become A by 2. So this is again equal to rho into 4L divided by capital A, or this is again 4 into rho L by A. So from this equation we will get rho L by A is 12. So this will be equal to 4 into 12. So this will be equal to 48 ohms. So new resistance of the conductor when length is doubled and area is halved is 48 ohms. Okay. Then next is seventh problem. Combination. It is from combination of resistances. Here two resistors are connected in parallel and one is here. Okay, so actually we need to find out the equivalent resistance across X and Y. So equivalent resistance we need to find out. So here this is 5 ohm resistor and 15 10 are parallel. So first find out the equivalent resistance when two resistors are connected in parallel. So 15 parallel 10. 15 parallel 10 means equivalent resistance. How we can find out equivalent resistance? 15 into 10 divided by 15 plus 10 will give the equivalent resistance of this parallel combination. Okay, this is equal to 15 into 10 divided by 15 plus 10. This will give 15 plus 10 25 2 5 6. This will give 6 ohms. Okay, so parallel combination of 15 ohm and 10 ohm will be equivalent to 6 ohm resistance. So 5 ohm in series with this 6 ohm resistance. So this is what in between X and Y. So 5 in series with 6 means total resistance is 5 plus 6, that is 11 ohms. So 11 ohm is the total equivalent resistance across X and Y. Okay. Then next is again we need to find out the current flowing through the circuit. So to find out current flowing through the circuit we need to find out the equivalent resistance R. Then we can find current using this equation V divided by R. So again we need to find out equivalent resistance. Here 6 parallel 6, this one. So this combination 6 parallel 6 gives a single resistance. Then 12 parallel 6 parallel 4. 12 parallel 6 parallel 4. Okay, so this will give again a single resistance. So these two resistors are in series. So we need to add up these two resistances to get total resistance. Okay, so 6 parallel 6 gives 6 into 6 divided by 6 plus 6 is nothing but 3. Okay, so 6 parallel 6 is 3 ohms. Then 12 parallel 6 parallel 4, 3 resistors are in parallel. So first take 12 parallel 6. Okay, 12 parallel 6 gives 12 into 6 divided by 12 plus 6. This is equal to 4. So again 4 parallel 4. Okay, this 12 parallel 6 is 4. Then 4, that is again in parallel with 4 ohm resistance. So 4 parallel 4 gives 4 into 4 divided by 4 plus 4. It is nothing but 2. So this 12 parallel 6 parallel 4 is equivalent to a resistance of 2 ohms. That means 3 ohms in series with 2 ohms. 3 and 2 are in series means 3 plus 2 is total resistance. So our total is equal to 3 plus 2 is equal to 5 ohms. Okay, so resistance we got as our total 5 ohms. So current will be equals V divided by R total, that is V is 20 volt, resistance is 5. So 20 divided by 5 is 4 ampere. Current is 4 ampere. Okay. Then next is based on Kirchhoff's law. So here we need to find out, first we need to find out the current. So here we need to apply KVL. So for applying KVL, first we need to fix the direction of current. So it is taken in clockwise direction and it is marked as I. Since the direction of current is this, voltage drop across R1 direction, sign of or polarity of voltage across R1 will be like this: left side plus right side negative, because current is flowing from left to right. Then again for R2, left side plus right side minus. Then for R3, right side plus left side minus. This will be the polarity. Then by applying KVL, analyze the circuit like this. Okay, so as we go like this, E2 E1 in E1 we are moving from negative to positive, that is there is a rise in voltage, so plus E1. Then this will be voltage across R1 will be negative because we are moving from plus to minus. So minus voltage across R1 will be, if the current is I, voltage across R1 will be I into R. So minus I into R1. Then next R2 minus I into R2. Then again minus E2. Then again minus I into R3 will be equal to 0. Here we are again, E1 is, we know that 36, and in this IR1, IR2, IR3 we are taking minus I outside, so it become I into R1 plus R2 plus R3, then minus E2. E2 is 6 is equal to 0. So 36 minus 6 is 30. 30 equals I into R1 plus R2 plus R3. R1 plus R2 plus R3 is nothing but 3 plus 4 plus 3. It is 10. So from this we can written as I is equal to 30 divided by 10, which is equal to 3 amperes. So current is equal to 3 ampere. So current is equal to 3 ampere. First question, answer of first question. Then B part is power consumed by 4 ohm resistance. So power, we know that equation for power is V into I or I squared R or V squared by R. So here we know the current flowing through the resistance. So we can use the equation I squared R. So I is, we find out the amount of current as 3. So 3 square into R is 4 ohm. Okay, so 9 into 4, 36 watt. Okay, then C, voltage across 3 ohm resistance. So we know that voltage is equal to I into R. So I is 3 ampere, resistance is 3. So 3 into 3, 9 volt is the voltage. Okay, then last question. In the circuit, first one find out the current through 6 ohm resistance. So we need to find out the current in 6 ohm resistor. So here we will apply current law KCL. Okay, at this node A. Okay, so for that we will mark the direction of current in this branches I1 and in this branches I2 and in this branches I3. So here I1 and I2. Since the direction of this current source is upward, we marked the direction of this current I1 as same as that of 5 ampere current source. Then direction of I2 is marked as the same direction of 4 ampere current source and I3. So from this I1 and I2 are entering into the node. So I1 and I2 should be plus and I3 is leaving from the node, so it is minus. So I1 plus I2 minus I3 is equal to 0, or we can written as I3 is equal to I1 plus I2. So I1 is nothing but it will be equal to 5 ampere. Okay, then plus I2 will be equal to 4 amperes. So total current I3 or current flowing through 6 ohm resistance will be 9 ampere. So answer for first question A is 9 ampere. Then voltage across 5 ohm resistance. Then 5 ohm resistance, voltage is equal to I into R. So current flowing through 5 ohm resistance is nothing but this 5 ampere. So 5 into resistance is again 5, so 25 volt. Then C, power consumed by 10 ohm resistor. So power again equal to I squared R. We know that the current flowing through the resistance. So we can use the equation I squared R, P is equal to I squared R. I is the current flowing through 10 ohm resistance is nothing but 4 amperes. So 4 square into 10, that is 16 into 10, 160 watt. Okay, so this is all about the numerical problems based on first 2 lectures. Thank you.